Do you think that doing good theoretical analysis and doing that in conjunction with the development of algorithms leads to better, more practical systems?
Yes, of course. Data sets nowadays are mostly fairly big, and so you cannot just rely on hacking to get speedups you need. You really need something which works well in asymptotic sense. So asymptotics is very, very relevant now. On the other hand, there is a big gap between theory and practice often, and you really have to fill this gap. And most developers, it's hard for developers. They don't have the background, and also they don't have the time to read the latest paper, and within the time they have to develop a product to implement the best algorithm. So I think it's very important to come up with theoretically good algorithms and investigate their practicality and describe their practical variants.
And do you see that happening by people working in teams, or do you think people, like each individual has to be expert in both the engineering side and also the analysis?
No, it's best done in teams because there are some individuals who are good at both, but in general there are people who are better at inventing new math, and there are people who are better at sort of engineering new algorithms. So it can be done in teams or through the process of scientific publication. Someone publishes a theoretically good algorithm, and then someone else gets a good implementation of it. For me, algorithms have several components. There's a mathematical component of algorithms, which is formal analysis of algorithms, where you prove P-go bounds. And then there is an engineering aspect where you try to implement the fastest algorithm you can on a real problem. And I like to take the approach which is based on scientific method, which combines the two approaches. So you sort of observe the real world, make some computational models, and then you try to design an algorithm for it and prove some things about it. And then you implement this algorithm and see if it performs as theory predicts. And if not, you try to modify the theory and either better explain the behavior of this algorithm or invent a better algorithm.
How do you even measure the asymptotic running time in practice? Do you run on bigger and bigger random examples, that sort of thing?
It's easy on synthetic data. Yeah, if you have a certain generator where you can set parameters, then you can measure how the algorithm does. On real world data, it's much harder.
Yeah, right, because it doesn't necessarily scale in a natural way.
And also for road networks, for example, there are only two natural examples, namely Europe and North America.